Hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem. Form a palindrome. So what the problem is saying is we'll be given a string and we want to find the minimum number of characters to be inserted to convert it to a palindrome. Okay. So first of all, let's see what is a palindrome. So what is a palindrome? Everyone knows, right? So if the given a string, right? If we start from the left to right, right? Or if we start from right to left, the word which will be formed by iterating both left to right or right to left, it is going to be the same. Okay. So this is a palindrome. So what we want to do is if for example, right? For example, let's see if there is a string called ABCA. Now what we want to do is in order to make this string, a given string, a palindrome, okay, how many number of characters, minimum number of characters we want to insert. So we want in order so that the string becomes palindrome. So we want to return those minimum number of characters. Okay. Now, how can we solve this problem? Okay, how can we solve this problem? So what we can do is, we will reverse this string. Okay, we will reverse the string. Okay, for example, so A, C, B, A. So okay, so this is a reverse string. So after post reversing, what we are going to do is we will find out the longest common subsequence of the string. So what is the longest common subsequence, right? So the longest common subsequence is the common characters, the longest common characters, okay, in the string, and they need not be contiguous, right? For example, here. So what is the longest common subsequence here? A, right? C, right? So see, if you see here, so these ACA is the longest common subsequence, right? So these are not contiguous, right? ACA is not one after the other. So there is some B string, right? B over here. Okay. So here, what is the longest common subsequence? It is ACA, right? Now, so what we are going to do is once we found the longest common subsequence, right, which is ACA, we will take the string length. What is the string length? String length is 4. And what is the longest common subsequence? It is 3. So what it will be? The minimum number of characters to be inserted, it is going to be 1. So how? So that's what, right? So what is the length of the string? VR. So the unmatched string, for example, here ABCA, right? So the length of the string was 4, right? And here the longest common was 3, right? And what is the difference? The difference is 1. So it is saying we need to insert one character in order to make the string palindrome. So how it is? So here it is. If we insert B over here, right? The one character. So it will become palindrome. If you see ABCBA and ABCBA, right? Right? So this is the intuition behind solving the problem. I hope you have got the intuition. Okay. So now the problem all drills down to finding the longest common subsequence, right? Longest common subsequence, and then simply subtracting the longest common subsequence length with the string length. Okay, so that's the intuition behind solving the problem. Okay, so now what we are going to do is we will reverse the string. Okay, we will reverse the string ACBA, right? And we'll pass these two strings, right? These two strings to the longest common subsequence function. Okay, now how we are going to solve the how we are going to calculate the longest common subsequence? So for example, right? So we'll start with the last characters n, for example, and m, right? So we'll see. Okay, if both these characters match, then we will decrement both our n and m, right? We'll increment our LCS with as 1, right? Because these two characters are matching, right? Then we have decremented both our n and m. So here we'll compare again both the characters, right? C and B. They are not matching. So in this case, we'll have two choices, right? In this case, we'll have two choices. One would be to yeah. So one would be to consider to decrement m, right? M. So we'll consider these two strings. One will be, right, to eliminate this particular character. So what is one choice? ABC and AC, right? Another would be to decrement to exclude this particular character AB, right? That is decrementing n only, right? AB and ACB, right? AB and ACB. So why we are doing so we will consider those. We'll have two choices here, right? One choice would be this and one choice would be this. So whatever out of these two choices, right? And we'll again try to match the characters, and whatever maximum length it matches, right? We're going to take max of both these things, right? Out of both these two, we'll take the max, right? So again, we'll run our LCS again. So here C and C, right? N is here, M is here, right? It is matching. We'll increment our LCS again, right? Then we'll decrement, in this case, decrement B right? N and M, both. Whenever the character matches, we will decrement both N and M, right? So here it is not matching. So again, in this case, we'll have two choices again. In this case, we'll have two choices again. What the two choices will be? One is to not, one is to exclude B, right? One is to exclude B, A, right? A and A, right? And one is to exclude this particular A, right? AB and empty string. Okay. So in this way, we are going to find the longest common subsequence. Okay, so this will be the intuition behind calculating the LCS. So let me quickly code. I think you'll understand better with the code. Okay, so before going to the code, I'll request you to subscribe to my channel. Okay, because a lot of effort goes in solving the problem and creating this video. Okay, so let's quickly see what we're going to do. So first I'll show you the Java code followed by C++. So we'll create a string builder, right? String builder will create str. Why we are creating string builder? Because we want to get the reverse of the string. Okay, so what we'll do? LCS will create a function LCS, will pass our original string, and the reverse strings will take the reverse of the string to string, right? We took this and we'll also take the length of the strings, right? str.length. Okay. And here also for the second reverse string, the length is going to be the same. So let's consider the string length only. Okay. So we took this. Now what we're going to do, let's implement this function static int LCS. Okay. So string str1, let's call it str1, string str2, int n, int m. Okay. So we took this. Okay. So what it is going to return? It is going to return the length, LCS length. Let's call it LCS length, right? Okay. Now what we are going to do? Simply, first of all, we are going to check. We are going to start with the last characters, as I said, right? We are going to start with the last characters, right? So we are going to check if str1 char at n minus 1, right? Because we are passing the string length here. The string length here, that is why we have to do n minus 1. If it is equal to str2 dot char at m minus 1. Okay, in this case, what we are going to do? We are going to increment the longest common length 1 plus, right? Because one character is matching. And then we will call this LCS recursively again. So we'll pass str1, again str2, and this time we'll decrement both n and m because both the characters are matching from both the strings, right? N and m, right? If it does not matches, if this character does not matches, then simply, as I said, right, we'll have two choices. We'll have two choices, right? So one would be this ABC and AC we took. And so one wherein we are going to, let's say, and we'll take the max of it, right? So math.max LCS will pass both strings str1, str2. In one of the thing, we are going to decrement n and we'll keep m as is. Okay. In another choice, I've already explained this. In another choice, we are going to keep n as is and decrement m, right? So that we are increasing the probability, right? Okay, of having longest common subsequence length. Okay, so this is the uh, business logic, okay, behind calculating the LCS. Now let's have base condition. If n equal to 0 or m equal to 0, that is we have reached the end of the string, right? Okay, so we'll simply, what we'll do? We'll simply return zero length, right? Zero length. Okay, because we have exhausted the string. Okay, so here it is LCS. Okay, now since we are calling this recursive function twice, right? And at each point we are calling twice if it does not match, right? So we may get stack overflow. So what we are going to do, and for example, we are going to use memoization, that is dynamic programming, right? Dynamic programming. So what we are going to have, we are going to have a DP array, DP equal to new int. What we are going to take the length as string.length plus 1, right? Extra, 1 extra, right? Okay, n and m both are same, right? And what we are going to do, we are going to initialize the DP array with -1, arr DP, right? DP, and what are we going to do? Arrays dot fill arr with -1, right? We did this, and we'll simply pass DP as well in our LCS string. right? So here is our DP array. So first we'll check if for first of all, let's first assign whatever we calculate, right? DP of NM, right? DP of NM, where we are storing the length of the longest common subsequence for this particular NNM at DP of NNM, right? And here also will store, right? N and M equal to this, right? So now what we're going to check if it is already stored, right? If it is already stored, N and M. If it is already stored, -1, then what we'll do? We'll simply return, right? No need to go further the recursion, right? We'll simply return whatever is stored in DP of NNM. That is, this was calculated, right? So we have this LCS length now. And what we'll do? We'll simply return string length minus LCS length, right? That's what I said. I hope you've got the solution. Let's quickly compile this. We got some solution cannot be applied. Okay, here we have to pass, right? Yeah, here we have to pass DP as well. We missed this. DP. Any other error we have? Here also. Sorry again. DP. Yeah. So let me submit it. So here it is, the test cases seem to pass. Yes, they have passed. I hope you have got the solution. Please subscribe to my channel, like the video. I've observed that 90% of the viewers don't subscribe to my channel because please, I would request you to subscribe as it is going to be motivating for me as well. Okay, let's quickly see the C++ code. Okay, so here is a C++ almost same, right? So what we're going to do, so we are going to take a string, right? And we are going to reverse that string, right? And we are taking the length here. We are having this DP two-dimensional array. We are initializing it -1, right? And we are passing the string, reverse string, NNM and DP, right? And here, again, the base condition, if NNM both have exhausted, right? Then we'll simply return 0 as a length. And then here, if it is already pre-computed, it is already computed, this particular part was already solved, then DP of return DP of NNM. Or here, if it is not solved, we are going to check if the character matches, then simply call the LCS again with decrementing both N and M, right? And storing it into DP array, right? And then if it does not matches, then decrement N in one choice and decrement M in another choice, okay? And take the max out of these two, right? So we'll store this DP and finally we'll return the length minus the LCS length, okay? So this is a solution. I hope you've got the solution. Thanks for watching. Have a happy, healthy, and a great day. Thank you so much.